Hello everyone, this is Yogesh from ailuge.com. Today we're going to discuss about generative AI. So basically what does it mean by generative AI and the pipeline of it. So basically we also understand what are the components that is involved to create a simple generative AI application. Let me go back to my screen. Okay, so we're gonna first discuss about generative AI and then we're gonna discuss about the pipeline of generative AI and each component of that, which is data acquisition, preparation, engineering, modeling, deployment, and then finally update part. So what is generative AI, right? If you just see the name carefully, generative AI, generative means something that can generate, right? That can produce, that can create, that called the generate. And then there's AI. So basically the AI system which can create or generate some new content that could be called generative AI. So very simple language, generative AI is a AI system that can create the new content. The content could be your images, text, audio, video, code, etc. And how does it do? It does by learning the existing data. So in the last video, I talked about LLM and the large language and the language model, where we have seen the goal of LLM was to take the query from the input from the user, sorry, and then finally get the output, right? Generative AI basically uses the LLM model to create the content, right, from the existing data. So let me take you little back. We heard machine learning, right? Inside machine learning we had a couple of model like linear model and then there is a non-linear model as well. This whole linear non-linear model, which is like linear regression, decision tree, random forest, XGBoost, all sort of pieces came together and they called us ML model. When we come to deep learning, under deep learning also there is like ANN, RNN, CNN, YOLO, all those models that fall under that category are counted as DL model. Similarly, when we come to generative AI when we say, it means that on the back end we are talking about LLM and then there is a large language model which we have discussed in the last video, right? So this is basically the generative AI umbrella, and there are a lot of things right now adding up in this umbrella, and that whole will become your ultimately the generative AI. So generative AI is what? It's just a AI model which is trained on huge corpus of data, the text, audio, images and anything, and can produce the same data back based on the user query. So for example, you ask LLM what is the capital of Germany, and it will say the capital of Germany is Berlin. How does it say? Because it has a predefined notions, predefined existing data, large corpus of data from Wikipedia, Google, different lot of websites, government websites, and all sort of data are involved to train this model, and that's how the LLM model knows what is inside my backend basically, and accordingly it does the answer, right? So the key idea is just not to analyze. In earlier model like ML and DL model, we used to know the labels, what is the input level and what is the output level. So let's suppose if I want to classify whether it's a dog or cat, we already knew that it gonna just give either one of the category, either dog or cat. It cannot say that it is a goat, right? Because there was no functionality defined in such a way. But in LLM we are not restricting anything. It could basically say that no, it is not really dog and cat, rather it is a goat. So that's the capability of generative AI. It can basically, mimic the pattern similar to what a human mind does. It can basically think, it can give the logical reasoning behind that to finally create the content. Some examples are ChatGPT, which can be used for text to text conversion. Basically, you can assume it. Sentiment analysis is there. A lot of basically things you can plug and play. Here you can include the images as well, where the Delhi model are there. You can ask the model to create the imaginary image. For example, you are sitting in a horse and riding in a moon. if you give that as a prompt to the model, it will generate the image of similar kind. So that's a capability now the LLM model basically brought. And then there's a voice control also, and then the code control also. One of the biggest examples is GitHub Copilot. GitHub Copilot is something where people used to write 10,000, 20,000 lines of code in a day's time, or sometimes it took months as well. But right now, with the capability of GitHub Copilot, we could do it in a few hours, that whole job. So that has basically shifted the whole change in total of world of AI basically. So very simple. Generative AI is nothing but it's a big umbrella. Under that, lot of models are involved. LLM model, LM model, and different kind of LLM models are there. We discussed in the last video again. Now, if you have not seen, please go and watch that. And that system basically, does the job for you, which is the creation job, or maybe, building something, some new content job. Now, when we talk about the pipeline, so just like any other model, generative AI application or the whole framework also need to cross through all these, the components. First and foremost is the data. So we need to acquire the data. Second is pre-processing, which is cleaning and doing, ready data for your modeling purpose. Third is extracting useful informations from the extracted data. Finally, fourth is you're training the model or tuning the model. Anything is fine. Then your validation of the model, whether the model is really performing, really useful. After that, we're gonna deploy it in the cloud for the public use, and then basically our consumer can use that model. And finally, which is very very essential step, is monitoring. So once you develop it, once you deploy it, you need to monitor it, how it's basically perform in the outer world, and we need to capture each and every information so that we can rebuild. And this whole cycle will continue basically over and over until it is basically lot more mature. So that's the basically whole pipeline. We're going to discuss it each in a detail. So first, when we talk about data acquisition, right? Data acquisition is very simple. We need to collect the data from wherever it is possible. It could be from SQL database, it could be from the external files, it could be from internet, it could be the manual data entry, anything. Just that we need the data, right? So that's the collection of data. But in the real world scenarios, it is not always easy that we can procure the really relevant data, right? In that cases, we might need to use the augmentation technique. And what are those? The synonyms replacement, bigram flip, back translation, and noising, right? So synonym replacement is nothing but, let's suppose in English we have like good. So good synonym could be like nice. So that way we basically put the lot of data, synthesize the data from the existing data set, and the corpus will become huge now. Bigram flip is nothing but, let's suppose I say I am Yogesh, and the other way could be Yogesh who I am right now. So active wise, passive wise, basically you can assume it, and that's a bigram flip, and that's how you can increase the data. Same way, back translation and the noising information also can act to increase the database from our side, and then model get enough data to train it. Coming to data preparation part, data preparation is nothing but cleaning the data and transforming this raw data information to a structured format so that our model can basically use this data set, right? And how can we do that? Using tokenization, stop word removal, stemming, lemmatization, all those techniques are there to clean the data. For example, you have like HTML tags in your data, you have boilerplate text, you have like some emojis are there, you have repeated contents are there. So those information which is very very irrelevant, or will not create a lot of value for our use case, probably we might need to remove it, and that's why the data preparation thing will come into picture. Just to give one context, these techniques are already inherently present in our LLM models. We don't need to do it explicitly by ourselves, rather the model itself does this all the cleaning part. So that's a great win in the world of AI. But otherwise we used to do basically all these jobs in the older time period, which already have been automated by the LLM models. The third part is feature engineering. So now once we clean the data, we need to convert the text data into numerical feature. We also need to extract some of the useful information from the existing feature. For example, you have date features. In that date feature, you could extract like month, you could extract day, you could extract year, you could extract which week it is falling, and a lot of information you can get it from the feature what is already present, and that can be used for the modeling purpose. That will add a extra value, add a extra information to the model, and to basically to does more robust training basically. Now lot of features are there, lot of techniques are there. One hot encode, bag of word, TF idea, which is term frequency, inverse document frequency, word embedding, and transform embedding. So now at recent we are using embeddings. Embedding is nothing but identifying the attributes. So for example, very famous example of king and queen, right? So let's suppose we have king, this arrow is king and this arrow is queen, right? Now all when we talk about embedding, we talk about the attributes of the particular entity. So king has some attribute, queen has some attribute. What could be that attribute? Like for example, king is a human being. Yeah, first, king basically has a lot of wealth. Second, king is something like king has eyes, king has legs, king has ear, and xyz. Similarly, when we talk about queen, queen is also human being, queen is also wealthy, queen has also eyes, leg, uh, a body, and then here king is male whereas queen is female, right? So those kind of attributes basically define an entity in the embedding, and embedding represent a very huge context. When we talk about just a king and queen, you might see male and female, but in the world of embedding, it basically has a lot of parameters included in that vector. So any entity when we tokenize and fall under embedding, it will have a lot of context rather than just seeing the name or maybe the one or two attributes, right? And that's how the LLM model have lot more understanding. So take an example of Apple. Apple is a product which is like iPhone, MacBook, and all sort, and Apple is a fruit as well. So when we pass Apple, the LLM model basically takes and also understand the attributes of Apple, whether it is really a fruit or it is really a product which I am talking about. So that's how the LLM model is more robust, more understandable, and more context generated basically information it is there. We will talk more about the embeddings in the future videos, but yeah. Then modeling. So in this phase, there's a two options are there. Either we want to use a pre-trained model which is already present. Let's suppose OpenAI has exposed their own APIs. Anthropic has owned their Cloud Sonnet and all other model APIs, and then Google has Gemini and all sort of. And there are a few OpenAI models also present like Llama, Mistral, and all sort of open models are also present. So we can directly leverage it, but in those models we can we can just use the predefined context whatever they have been trained on, right? So it will be very generalized, it's not like very domain specific. Yes, we have an option of fine tuning, but that will be very generalized one. Then second is training. Training is where we want domain specific. Suppose I am working in a pharma domain. So probably my model is not so much exposed to pharma because pharma information is not so readily available in the internet. No company share the drug information at very easy manner, right? Because that's their whole business model. In that scenario, I want to train my model to pharma domain, and what I do, I basically train my model using the fine-tuned data, and I'll prepare the data in such a way that my model understand okay what I'm trying to convey it, and how do I want to extract the information, and that's where the RAG and all things will come into picture. We have a good pipeline in the coming videos, so please do watch that videos as well. But yeah, uh, those are the techniques through that we can use the modeling technique as well. Few open source model are Hugging Face. We have a lot of library like Quen, and then Llama, Mistral, everything you can find in Hugging Face website. And then in a closed source model are Anthropic, OpenAI, and Gemini. All those are the closed source model which is maintained by an organization. Finally, the validation part. Once we're done with the modeling part, we need to assess whether the model is really useful, is really relevant, or really basically pass all the checks. All the quality checks has been passed basically. So multiple KPIs are there to check. Again, it is very specific to your business, but all general KPIs like intrinsic KPIs accuracy is there, and then blue matrix is there. That are the two intrinsic KPIs. Extrinsic means your real world performance. Suppose you pass some prompt like what is the capital of Germany, and let's suppose if it gave Berlin, well and good, your model is at least doing good. But if it failed to basically recognize what is the capital of Germany, that in that scenario you know that there is some flaw in the model. Then outcome alignment. Some models basically build to meet the goal. For example, chatbot. You apply some chatbot in your website and you track the behavior of consumer, whether by chatting with that chatbot consumer is converting in or not. So if it converts, it met the goal. If it does not convert, that means it is not able to meet the goal. Then context recall, also like how much context it can recall, right? That is also one of the validation criteria of the model. Deployment. So this is the place where our model really goes to real world for real user testing. Here there's a different ways we can expose to real world, which is like using your application, using a REST APIs, or using some platform like ChatGPT right now. So multiple ways through that a user can access our application. But when we basically upload this, or maybe allow the users to access this application, we need to ensure two things. First thing, the scalability, so that multiple user can access this application at multiple point in time, right? And secondly, it is secure enough, authenticated, so that people can use for the leverage purpose, basically for the real use purpose, and it is monitored so that it cannot be used wrongly in the wrong places, right? Because AI has a positive side, so it has a negative side as well. So we need to very sure, ethical, very monitored to what consumers are using, how they are adapting it, and how they are consuming it, right? Yes. So like how do you deploy it? There are multiple ways again, but the Docker container is one of the easiest way where you can create a build image, put it in a container, and then finally using the Docker you can deploy it in any of the cloud server. We're gonna cover Docker part in the coming videos. So yes, and then finally monitoring our update. So this is the last step in our process, but this is also one of the crucial steps, because we also need to monitor the user behavior, like how users are engaging, whether user is really finding easy to use or there is something difficult. So we need to also understand from the engagement, their activities, basically how much time they're spending, which part they are clicking most, which kind of queries they are searching. So all those pieces we need to track it. Then we need to take the feedback as well. So any application which has been built at the very initial is not that mature, but after collecting multiple feedback from multiple users and different horizons, it can be matured enough by reiterating again and again. So that's the collection of feedback, and then finally periodically retrain. So again, once we collect the feedback, once we understand the users basically interactive activities, we also need to take the action. So probably we might need to retrain the data, we might need to retrain the model, or maybe add some important information which might be missing in the iteration number 1 or iteration number 2. So that's how we basically make the model more robust and more usable, right, in the near world. So these are the pipeline in the generative AI. These are very common, which can be seen in the ML model, deep learning model, but generative AI also exhibit this basically pipeline. I hope you learned something from this video. Thank you for watching. Please do like this video and also subscribe this channel, and stay tuned for the next video. Thank you so much. Bye bye.